This is section 4.5, part 2. We're continuing to graph sine and cosine, but today we're going to start moving these graphs around with our transformations. Let's go ahead and get started. The first slide is just a reminder of our general equations for sine and cosine. We went through these in class, but it's to help remind you what the different letters stand for. Remember, the big thing there in terms of the period is that you have to do 2 pi divided by the b value. So moving along to the next slide, it's just going to be a free response question, and I just want you to go ahead and in your Google form, I want you to tell me the way that this graph is being shifted. I want to know its period, and I want to also know the amplitude. So I just want you to answer those 3 questions, and then once you do that, you can move on, and we will start looking at how to actually graph these. So here's our first equation, y equals 3 sine of 2x. The place I like to start at is just by going ahead and deciding the phase shift, the amplitude, and the period. So if we're trying to find the phase shift, it doesn't look like there's an h or a k here. So it looks like in terms of this graph, the phase shift would be none. It's not being shifted at all. So it's starting at the same point that sine would normally start at. In terms of the amplitude, remember that's the number in the front, and our amplitude in this case is 3. That means from our center line, this graph is going to go up or down 3 units. And then finally, the period. Now in this case, we do have a b value of 2. So in order to find the period, we'll have to do 2 pi and divide it by 2. And when I simplify a little bit, I get pi. So now that I know my shifting, my amplitude, and my period, I'm ready to go ahead and start scaling my axes. So I have to decide what's going to be the best scale here. Now remember, our graph takes 5 points to plot 1 period, and in 5 points I need to go from 0 to pi in a total of 5 points. So I think the best place to start in this case could be pi over 4s, and let's give that a try. So we're going to go ahead and just scale the axes in pi over 4s. We'll just count in pi over 4s. I'm going to start back at negative pi over 4, then it'd be 0, 1 pi over 4, 2 pi over 4, which is pi over 2, 3 pi over 4, 4 pi over 4 is just pi, and we'll just keep going from that way on, counting in pi over 4s and reducing when necessary. You could also use your unit circle to help you figure out the order of the pi over 4s with the reducing fractions as well. So your unit circle could help you scale your axes if you need it. The next thing we need to do is scale the y-axis. Now because the amplitude is 3, we're going to have to go up and down 3 units, so we want to make sure to go all the way from 3 to negative 3. Before we make our graph, let's actually just take a quick reminder of the sketch of sine x, just what sine x looks like. Now sine x, remember, starts at 0, 0, it ends at 2 pi, and it has a point right in the middle on the x-axis as well at pi. And then from there, sine goes up high and down low. And so those are the 5 points that we're going to graph right now. So the first point, because there's no shift here, it looks like our first point is going to start at 0, 0. Since the period is pi, the last point of this first one cycle of the graph is going to be at pi, because that's how long it's going to take from start to finish. Now I'm going to need to find the middle of those 2 points to find the next one, and you can do it a lot of ways. Hopefully a lot of you just see the middle of those 2 are going to be pi over 2. You could also say go in 1 and in 1, and then you can see right there that our middle is pi over 2. We need to find the middle again between 0 and pi over 2, and that one should be pretty easy to see that it's pi over 4. That point's going to go up high at 3 because the amplitude is 3. And finally, we need the middle between pi over 2 and pi. That one would be 3 pi over 4, and it's going to go down low, and we can get that sketch drawn in of 1 period of this graph. Now you can see that the whole cycle, one period of this is happening between 0 and pi. It's only taking half the circle to get through the entire graph. It's happening a lot faster. If I asked you to graph another period, you could just continue the same pattern, and you can sketch in another period. So it would end at 2 pi, the middle will be 3 pi over 2, find your middles again, and you can just continue that same picture. And you can keep doing it over and over and over again, depending on how many periods the question asks you to graph. So you can see that from 0 to 2 pi, this graph actually happens twice. We actually go around the circle twice. Let's go ahead and look at another example. So now we have a cosine graph. And once again, we're going to do the same thing as before. We're going to start with the shift and decide how this graph is shifting. Now it looks like it does have a plus h. Remember, that's going to move it to the left, and it looks like it's going to go left pi over 2 units. There's no k value, so this graph isn't going up or down any. There's no a, so a is just 1, the amplitude is 1. And there's no b value, so the period is just 2 pi over 1, which is just 2 pi. Now that I know those, it's time to scale my axes. Now between negative pi over 2 and 2 pi, I have to go 5 points. So I think we could just scale this in terms of pi over 2's and we should be okay. We'll start there and see how that works. So I'm just going to count in terms of pi over 2's until I get to 2 pi. And again, you could use your unit circle to help you there. And in terms of the y-axis, let's go ahead and look at the cosine graph. We'll do the y-axis in just a minute. The cosine graph, remember, starts up high, and it ends up high, and in the middle, you're down at the lowest point. Then the middles of those are where you cross your x-axis. So this one is going to look a little different for our first and last points. They're going to be up high rather than on the x-axis. So now, let's go ahead and, sorry about that. Now let's go ahead and sketch this. So the first point is going to be left pi over 2 units. So we're going to go back pi over 2 units. But remember, this one's going to start up high. So we're going to start up here at 1. So we're going to be at negative pi over 2, 1 in this case. Now, the last point is 2 pi units later. You can think of this a lot of ways. Normally it would end at 2 pi, but because I had to go left pi over 2, it's actually going to end here at 3 pi over 2. In between negative pi over 2 and 3 pi over 2 is a total of 2 pi units. And again, we're up high because it's cosine. We're going to find the middle of these two, so let's just kind of start counting in sum. Don't forget 0 does kind of count as a tick mark. And pi over 2 is the middle, and we're going to go down to the lowest point on the graph. Now if we find our middles again, we're going to get our x-intercepts. So in between negative pi over 2 and pi over 2 is 0, and the other one is pi. And now that we have all the 5 points drawn, we can sketch this graph. Now that's just one period. Notice it's happening almost in 2 pi units. Well, in 2 pi units, but it's being shifted back. It's starting back a little bit. If we wanted, we could continue and draw another period of this graph just by extending the pattern. And again, it's going to depend on the question and how many periods it wants you to graph. Let's take a look at another example here. So for our next example, you'll see there's a lot more happening here. We've got a shift to the right, we have a shift up, and we have an amplitude. So let's go ahead and check all those. And not only that, but our amplitude's negative. So the first thing is the shift. This graph is going right pi over 6 units, and it's going up 1 unit. So there's a change right there to start. The amplitude is 2, but it's going to be negative. Now, remember, that means in terms of the sine graph that it's actually going to start the opposite. It's going to go down first instead of up first. The period is still just 2 pi because our b value is 1. Now, in terms of scaling this axis, we're going to want to scale in terms of pi over 6's right now because that's how I'm going to shift the graph to the right pi over 6. Now, I have to go a total of 2 pi units, so it looks like this is going to be a pretty big graph if we're scaling in pi over 6's. And let's just go ahead and start counting our pi over 6's. We'll start at negative pi over 6 and go on from there. And so we'll just keep counting 1 pi over 6, 2 pi over 6, 3 pi over 6, and reducing when necessary. You could also use your unit circle to help you with these. Remember, you would be skipping the fourths in this case. So now as we graph this, or as we have this graphed. I'm going to end at 11 pi over 6 for now. You'll actually see in a minute we're going to have to extend it just a little bit further, and some of you might already see why. We need to think about the amplitude for a minute. Because the amplitude is 2, we're going to have to go 2 units in either direction. But this graph is being shifted up 1 unit. So we're actually going to have to need more than 2 tick marks on our y-axis. I'm going to go from -3 to 3 on the y-axis. Now, if we look for a minute at the sketch of sine, remember that's what sine looks like. But in this case, it is negative, so it is going to be doing the opposite because it's negative. And also, we're going to be shifting this up 1. I like to start with that k value, that shift, and I'm going to go up 1 unit. I'm actually going to draw in a dashed line. Now, this line isn't part of the graph, it's just the amount we're shifting it. The reason I did this is it's going to help me. I'm going to think of this as being my new center line because everything on the x-axis is going to go up 1 unit. So now I'm going to graph this just the way I normally did. I'm just going to pretend like that green line is my x-axis. It's my center line. So the first point would be to the right pi over 6, and again it's being shifted up 1 unit, so you can see our first points there. The next point is going to be 2 pi units later. Now normally that would end at 2 pi. But we have to go pi over 6 to the right. So actually this one's going to end at 13 pi over 6. And we'll put a point there. We need to find the middle. Now, a few ways you could do this. I like to think of the middle normally as being pi, if it was between 0 and 2 pi. But we're going right pi over 6. So it looks like the middle is going to be 7 pi over 6. You could also just start taking off 1 on each side all the way until you get to your middle, and you can see that that's going to be 7 pi over 6. We'll find the middle again, and the middle again ends up being at 2 pi over 3. But this one's going to go down, and now from here I actually have to go down 2 units. And let's fix that point. That point's not in the right spot. From the center line, we're going to go down first because it's negative, and from the center we're going to go down 2 units. So it looks like this one's going to actually end at -1 down here. We'll do the same thing on the other side, and it's going to go up high to +3, 2 units from the center line, and we'll sketch that in. Now this graph looks like it's taking a lot longer to complete one cycle, but if you pay attention to the axes, we're just scaling it in a smaller scale, so it takes a lot longer on the graph to create 2 pi. So really this is still happening just in 2 pi units, it just looks a lot more stretched out because of the way we scaled our axes. Here's your multiple choice question. It's just a matching. I want you to match this equation here, 2 cosine 1/2 x plus 2, to one of the graphs below, and then that's where we'll end for today.